Today's lesson is based on our civil drawing, whereby we are given these two views, which is your floor plan and your sectional elevation. Both these views are incomplete. What is important is that we first read what is it that we need to do. What is it that we are given? It's an incomplete floor plan, an incomplete elevation of a room showing the foundation, walls and slab. And we are given the window and a door and a frame profile. So we have this sectional elevation with walls, with foundation. They're showing us the ground level, and they're showing us the slab foundation, which is all of this is incomplete. They are showing us the floor plan, the position of the window with the code W, the position of the door, as well as the walls, of course, with the cutting plane. Now we need to draw this to scale of 1:40 in first angle orthographic projection. Every dimension that is given to us here must be divided by 40. And then we need to complete the floor plan with windows and a door. So this is in first angle orthographic projection because this is in paper 1, and this is what we see as a top view, but in this case it's known as the floor plan. And here of course we have our front view, which will be called sectional elevation. So we need to complete the windows because the doors are, the windows and the doors, because the walls are already there. We're going to be using the cutting plane AA to get this completed. Now what we'll need, that you need to have your A3 paper with the title block and an appropriate title. You need to hatch according to Sense 10143. You need to put all labels, scales, abbreviations, Dpc, your NGL. That must be indicated in the correct view, of course. You need to do some calculations regarding the floor area and the perimeter using this floor plan. So now, the first thing that we need to do is to draw this as it is given to us, then complete whatever that is not included on this drawing. We're going to divide each dimension by 40, which is the scale that is given to us, and then we draw this. So now we have to quickly look at the window sizes, which is 2000, which fits in there, and our window has a window sill. The window here is 240, but the wall is 200. So it means that 240 is for the window sill, the extra 40. Here we have a steel frame, which is given to us. It says here it's 44 away from that, and this is your wall. And the door is 900. Remember, the door must always be open. It must be drawn open. So this is the information that is given to us. So now we're going to move to where we are drawing all this that is given to us. So there's our floor plan, almost complete. So if they're saying to us the window is 240, so it means the window is a little bit bigger than the wall itself. So if the wall was 5 millimeters, so it means the window should be about 6 millimeters. That's why I'm going to do this. So in other words, I'm now extending the window. That's the extension, and that's the extension. That's the extension of the window. Of course, we don't need these two things here, and we don't have to have that wall line anymore. We don't need the wall line anymore, because now we are saying we are extending the window. And then we're getting what we call the window sill. This may not be given to you, so you must assume the distance there in good proportion, but not more than 2 millimeters. Now we need to draw the frame of the window. Minimum lines here is supposed to be 2, but we get to do 3. I'll explain to why it's 3. One line is for the frame, another line is for the frame. The 2 outer lines are your frame lines, and this line here is your glass. Maximum 3 lines, that's fine, but you can draw 2 lines, so you can do it like that. That's a minimum of 2 lines. Why it's minimum 2 lines is better is because the distance from there to there is actually 2 millimeters, so you can draw 2 millimeters, but when you draw 3 lines, then it becomes 1 millimeter, it becomes too small. So this is how we draw the window. So we're going to move on to the next window, which we know we're doing the same thing. We say the window must be about 6 millimeters. So in other words, we have now extended to fit our window sill, and this is what it looks like. When we have the window sill, we then say this wall line must now go away. Alright? Then we can see that is a window. So now we must find the midpoint here. That's our midpoint. So in other words, this is 3 millimeters from there to there. Now after finding the midpoint, it means now we must draw the 2 lines which represent the frame. The 2 lines, 1 and 2. So those are our 2 lines. Minimum 2 lines, maximum 3 lines. So I'm going to move this line away so that this is how I draw the window. So windows complete. Now we move onto the door. Now there's nothing happening on top, but the door is right here. So if we look closely, I'm going to move this line away. What do we mean by this? We say this is the inside of the room. When we're inside the room, the floor level is the same. But once you step outside, when you step outside, you're stepping lower. So in other words, when you're stepping lower, it means now you have to change the direction. So that is why we have this line there, because we're saying there's a change of direction. When you step outside, you're stepping lower, but when you get inside, you're getting higher. So this here is the same level. That's why we move that line. So another thing that is very important, the position here, the line here or the wall is shorter compared to this wall. So the door always opens towards the shortest side of the wall, which becomes this side. So the door will open and swing towards that direction because this wall is shorter than that wall. So now we need to draw, I'll bring in the frame. So now this is our steel frame which we have constructed using 1 millimeter away. So now we need to position our door here. This is where your door will be swinging. So we're going to draw a line at any distance. Let's just draw this door line now. We're going to draw a line at any distance for now. Right. And of course we draw another line, and that line must line up with this frame here. Line up with this. Why do that? It's because we know that the door will swing at this corner. So there must be a gap here for the door to close, come in that direction. Now we need to get our compass, place it at this point, open it to that position, because that's where the door will get into, open to that position, and it means our lines were short, so it means now the lines need to go and touch the circle. Now that's your door. So the door swing is this here. That's your door swing. So it's going to swing until it gets in there. So this is how then we get to draw the door. So that is your door, swinging towards the shortest wall of this building. So now that's complete. So it means we can now do the hatching. And the hatching must be a common brick type of hatching, where you hatch in at 45 degrees, 45 degrees, 45 degrees, 45 degrees. Now your drawing is now complete except for placing in your labels. So now we're going to place the labels. This is known as a room. The floor finish here, we assume that it will be tiles. Now the floor plan completes with the labels. Plan, scale of 1:40. Room designation is just a room. We're not sure whether it is a kitchen or a bathroom. That's why we're saying a room. And the floor finish here is your tiles. So all that you needed on the floor plan is now complete, and the drawing is now drawn dark. Now we need to move on to the sectional elevation. This has been drawn already. So now for you to complete everything here, you just have to do the hatching. Of course, when you drew these walls, it meant that this must line up with that wall. So that's how you project them. You project from this wall, and then you are able to draw this wall. So you'll do the same thing on the right hand side. Now, how then do you position the foundation? We then say, if this is 5, so this is the midpoint, then it means dividing by your scale, this is halfway, you go half on the left and then half on the right hand side. That's how you get your foundation. Then you follow all your dimensions to complete the rest. All the time, the view must line up with the floor. So with regards to sectional elevation, as we said, almost everything is done here. So all we need to do now is do hatching. Firstly, we will hatch the walls, which is common brick. We hatch the walls. We will hatch the walls. Common brick, meaning there's 2 lines. On the walls itself, there's one more thing that is missing here, your Dpc line. You draw your Dpc line, that's one. We do the same thing on the left hand side. We draw our Dpc line. So there's our Dpc line. What you need to make sure now is to darken this line. Okay, so that's your Dpc line, and on this side also is your Dpc line. Now once that's done, then we move on to hatching our anti-stepped earth. So we're going to hatch our anti-stepped earth with earth. That's hatching anti-stepped earth. If you look at this here, it's a horizontal line and vertical lines. Now we need to change the angle because we use a 45 degree set square. So that's how we then change it. Now we get our 45 degree hatching. Now here is your hardcore fill. This is your hardcore fill space. We then draw a 45 degree line also. We use a 45 degree set square. So we're going to draw a 45 degree line. It went to the wrong place, so let us quickly repeat it. That's our 45 degree line. Of course, we're going to let us make sure that it ends on the right place. So you're going to repeat this process right up to the end. You're going to repeat this process right up to the end using your 45 degree set square. So you're going to repeat it right to the end using your 45 degree set square. And then once that's done, then what you'll be left with, you are now left with completing or hatching the foundation and your floor slab. And your foundation floor slab is hatched with concrete. So the concrete that we need is that one. Then we hatch this, we hatch that, and we hatch here. So these are the three things that you need to hatch. Of course, yours is done in pencil. It will differ from what I am doing right now. So once that's done, so this is what it looks like. We may have to change the angle here so that it looks rather the scale, so that it's quite visible. Let's quickly change it so that we can all see it. Maybe we should be going down so that it's very much clear. You will be using your pencil in hatching this. Now there we go, there's your hatching. So hatching is done. The only thing that is missing now is your labels. So we're going to do the labels. Of course, we said that must be complete. Now your labels are completely done. You have this label, sectional elevation. You have NGL line here. This is your DPC. You have finished floor level, which is FFL. You have your DPC. You have your NGL. So all the labels that were required are now done. So all you need to do now is to do some calculations on this, the area calculations, as the question required you to do. So in that case, this is said to be a certain amount, and that also. So I'm going to do that calculations now. So this is our area calculation, where we said this is 4 meters, that's 3 meters, that's why we have 4 by 3 gives us 12 square meters, and this is our perimeter. Of course, there are many methods which we can use to get the perimeter, but this is the only method we can use to get our area. So everything that we need to know with respect to our civil drawing in grade 10 is right here.